My fellow Java devs, we are so back with our annual reminder to the Java haters that Java is not dead, is not slow, and your favorite streaming platform Netflix is literally built on Java. Because Paul Baker of Netflix spoke at JavaOne 2026 last month with a new How Netflix Uses Java talk, which goes into JDK 25, how ZGC is the default for everything now, and a silent bug in structured concurrency that you should probably know about if you're a Java dev. But it doesn't end there, because he also talks about how AI is utilized to help the Java developers within Netflix build Netflix. If you have no idea what I'm talking about, last year I made a video titled Netflix is Built on Java, where I took the most interesting bits of Paul's hour-long keynote about how Netflix uses Java and condensed it down into about 15 minutes. And then everybody had a great time in the comments section, loving Java because there's way too much Java hate out there, and that, well, we're here to combat that a little bit. And if you did see that video, just know that Paul's talk is about 50% new information, so we have a lot of fun stuff to talk about in regards to Java and AI. And like always, I highly recommend you watch his actual keynote, not just this video, but I'm going to make it regardless for all of you who can't sit through an hour-long keynote. And because I love talking about this stuff, it's a lot of fun. But let's talk about the basics. So Netflix is built on Java, and they have two different buckets where everything falls. One is streaming, so user-facing apps. And to clarify, the UI is not written in Java. It's written in whatever language is best or works on whatever device you're viewing it from. But the backend, the microservices, things like that, Java. So streaming, the user-facing apps that we see on our TVs, on our phones, on our computers, they have millions of users. Crazy RPS, are multi-region, aggressive timeouts, non-relational data. That's how that's built. And then they have another bucket, studio apps, because Netflix is not just a streaming service, but one of the largest movie production studios, or maybe just production studios in the world. So they have all of the apps that they use on that side of things that are quite a bit different. Not millions of users. So they have much lower traffic. They have relational databases. And what I find interesting is over there, they have a much lower tolerance for failure, which I guess makes sense because you can't just lose somebody's entire film schedule because the service retried or something. Whereas if it's on the user interface on the streaming side, it's not as big of a deal. But the architecture for both is the same. So a GraphQL request hits a federated gateway. The gateway fans out to a bunch of microservices they call DGSs, which stands for Domain Graph Services, which a framework for it is actually open source. GraphQL for Java with Spring Boot made easy, and they have a GitHub page with all of the documentation about it. And that is all built on Spring Boot. And when you look at the actual languages for the repo, it is about 80% Kotlin and 19% Java, which is actually a very important point because JetBrains, the creators of Kotlin, are the sponsor of a portion of today's video. But let me finish up the architecture talk before I talk more about Kotlin and how you as a Java dev can utilize it. So that's how that works. And then they have service to service, which is all gRPC. And federated GraphQL, in case that sounds confusing, is actually one big schema that is implemented by many different services. The gateway figures out which service owns the field and then stitches the responses back together. That's actually how Netflix can have this monolithic looking API that has thousands of microservices behind it. And then when you actually hit play on a show, it doesn't stream from AWS. And these little things, I just love these little things. Netflix quite literally ships hardware to internet service providers. There's about 18,000 different servers that they have sent out in this system deal called OpenConnect, which is just server racks full of SSDs. So when you click play, it's not coming from whatever AWS server, it's coming from a server rack full of SSDs at your internet provider's location, which is very close to you, and that's where the video bits are being streamed from, which saves Netflix money. Yes, shipping all of these out saves them money because of just the sheer amount of volume. It saves the ISP money, and then it makes everything faster for you, for us, the end user. And you know what all the management software is built on? You guessed it, Java and Spring Boot. And when Paul's talking about this, there's one small change that I noticed from 2025 to 2026. And last year, he said that Netflix has about 3,000 Java applications, whereas this year, he said there's about
3,000 or 4,000 Java applications,
which means that their Java use is growing, not shrinking. I'm just saying. And as we all know, anytime Java is brought up, it's always,
why not Rust?
For whatever reason, people want to bring up Rust in every conversation about every programming language, or the fact that Java is slow, this, that, and the other, or why not use any other programming language? Well, Paul says it better than I ever could.
To me and to us, Java is the best trade-off between runtime performance, developer productivity, and maintainability. Like, it's good at all these things.
And he compares it to Python, which has great productivity. You can whip up a script real quick, but it's slower runtime and worse maintainability because it's untyped. And then there's C and C++. So you get speed with C and C++, but not really faster than Java, actually, because you got to think about how Netflix operates. These are long-running server workloads. So when you look at Java, you have the JVM, or any JVM language, you have JVM's JIT compiler. It does runtime optimization that ahead of time compiler languages just can't. So for services that run for days or weeks, like basically everything at Netflix, JIT compiled Java will oftentimes catch up to or beat the speeds of C++. So keep that in your back pocket the next time somebody wants to say that Java is slow. And when Paul says Java, he also means Kotlin. He says that Netflix has quite a bit of Kotlin going on. And you probably knew this, but Kotlin was created by JetBrains, who's also the creator of probably your Java IDE, IntelliJ IDEA, as well as a lot of other cool tools. Like what they're building at JetBrains is awesome. I've been saying this for years. But what's cool about Kotlin is that you stop thinking about it as a Java replacement. Start thinking about it as more of being interoperable with Java as it runs on the JVM. And you can drop Kotlin directly into an existing Java Spring project. Now, while 27% of all Spring devs have given Kotlin a shot, and probably, if I had to guess, most of them like it, if you haven't, Kotlin typically will have 40% less code than Java to do the same thing, less boilerplate, null safety built in, coroutines with async that is really, really good. And they also have this framework called Coog, I think that's how you pronounce it, which lets you build AI agents right on the JVM. It's awesome. So if you haven't given Kotlin a shot, I'll leave a link in the description. Check it out, take a look. If you have already, well, then you know what I'm talking about and you know how awesome it is. And Spring Boot Netflix is mostly the same deal as last year, where they take open source Spring Boot and then layer a bunch of Netflix stuff on top of it. And where Paul actually goes a little bit deeper on this year is about testing. So they use the @Spring Boot test annotation, just the generic one, which I think is pretty cool. So they don't use the JDBC tests or JPA tests or anything like that. And he said it's because those are more so for single layers, whereas they want to test one functionality with these tests throughout all of the layers. So from the GraphQL layer all the way to the database layer. And they're only able to do that, test one component throughout all the layers using the generic Spring Boot test. The only issue with that is that it gets really slow, really fast when your app has thousands of beans. So what they did was they built custom test slices like enable DGS test that bootstrap just the framework pieces they need. Now it's time to get to how Netflix Java devs are using Claude Code specifically for a couple things, but a little bit of context first. Last year, Paul talked about migrating from Spring Boot 2 to Spring Boot 3, with the biggest change being the Jakarta namespace, which is swapping JavaX to Jakarta in every package name. Which, in case you're wondering why that even happened, years ago, Oracle changed Java EE to the Eclipse Foundation. And since Oracle kept the Java trademark, Eclipse had to rename everything to Jakarta EE. So the APIs didn't change, none of that changed, only the package names changed. And for applications, that's easy. I mean, right now you're probably thinking just find and replace all JavaX and make it Jakarta. You don't need, it's like the joke where all these new devs are like, oh my gosh, I asked AI to change every single instance of this word in my code base and it did. It's like, well, yeah, you could have just like Control F, replace all, and replace it. But for libraries, it's a little bit different. It's the chicken and egg problem. A library using javax.servlet works in Spring Boot 2, but not in 3. And you can't upgrade the library until all apps are on 3, and you can't upgrade the apps until the library is on 3. You see the issue here. So Netflix built a Gradle plugin that does bytecode rewriting at artifact resolution time. So when Gradle downloads a library, their plugin rewrites the bytecode to swap JavaX for Jakarta, which I think is awesome. And again, only works because the APIs are the same. They're identical. The only difference is the package name. And something else that's really cool is that Netflix open sourced this plugin. For actual code changes beyond the namespace, they used Open Rewrite and Gradle Lint. And Open Rewrite, if you haven't seen it, it's this open source tool that you write recipes, and these recipes describe code transformations. So rename this method, change this signature. It's very popular in big Java migrations. And this year, Paul confirms that they are done, complete with the Spring Boot 3 migration. After 2 years of running this tooling, everything is at Netflix is finally Spring Boot 3, just in time to start worrying about Spring Boot 4. And this is where it gets interesting. So this is where Claude Code comes into the mix. Because for Spring Boot 4, Netflix completely ditched their old approach. No more Open Rewrite. I mean, it was 2 years running that tooling. Instead,
for Spring Boot 4, we have decided to actually completely drive this migration through Claude Code.
So they're moving from something that is deterministic, Open Rewrite, to something that is non-deterministic, AI. And taking a look at how these really good developers at these big companies are utilizing AI, we can really learn from. Because they're not just saying, all right, every single developer install Claude Code and run away with this migration, or whatever developers would work on it. That would be utter chaos. What they actually did is they built a workflow engine on top of Claude Code to have it run headlessly as a batch job. And they're not just saying, hey, go crazy and migrate everything to Spring Boot 4, as far as we are told. What's happening is that every upgrade is a separate prompt that is running on a separate subagent, which, if you don't know, subagents in the context of Claude Code, since they're using it as a feature where you can spawn your own Claude instances with their own context windows for specific subtasks. So instead of just one massive conversation with all of the context, even with the context compaction and things of that nature, that muddies the waters and pollutes the conversation itself and just deteriorates over time. If you've ever experienced that, you know what I'm talking about. Instead, you get scoped work, and also scoped work that can, if allowed, and if it makes sense, work in parallel. And the results compose into a fully migrated Spring Boot app. And here's something that they do that I think is very, very smart, a good takeaway.
So that we can basically, as a person, can start looking at a project that failed and get the exact state of both Claude and the source code itself, where it started failing, or when we need to inspect it for corner cases that we missed.
Which what this is really doing is you're trying to mimic the deterministic tool. Because when you have a deterministic tool that fails, it'll tell you, like Open Rewrite, it'll tell you error is on line X. So when an AI agent fails, you also want some sort of reasoning trail so you as a human can go in and see where it failed and why it failed, and take a look at the conversation history and things of that nature, and be able to learn from it, also be able to fix the error. Now, we don't know how successful this is just yet, because this kind of just started. But Paul said it's looking really promising, and the plan, as long as all goes well, is to use this plan moving forward for all big version upgrades, from frameworks to libraries to what have you. And if you're wondering why Claude this time instead of Open Rewrite when it worked the time before, he had an answer for that.
It is actually really difficult to write things like Open Rewrite rules in a way that it takes care of all the different types of corner cases. And agents turn out to be much more flexible when it comes to these things, and also much lower cost for us to write.
And let me translate that for you. The Netflix Java platform team, one of the most sophisticated Java teams in the world, probably, evaluated deterministic migration tools against AI for migration, and are finding AI to do a better job, get the edge cases, the corner cases, and it's cheaper. And they're using Claude, which is the most expensive model out there. I assume they're using Opus, whatever the most recent Opus version is. But that all around is a huge takeaway. I mean, this really good team of really good devs are saying, yeah, AI agents do it better. That's pretty cool. But wait, before you get your panties in a bunch about AI praise, he specifies, and I think this was clear in what we were talking about before, is that it's not just AI. Like I said, you don't just let AI go willy-nilly. You start with the prompts. You figure out where Claude is inefficient, slow, wrong, and then you write deterministic scripts or programs to collect the data that Claude needs or do specific tasks for it. Then plug those back into Claude. It's a hybrid. It's almost like the developer is still needed. You are a software engineer. You do the engineering. You use tools already. Just use AI as a tool that helps you. I don't know how many times I have to say that. And there's also a question out there. If Spring Boot 3 is working just fine, why immediately upgrade to Spring Boot 4? And no doubt this is coming from all of the shops that are still on Java 8. Sorry if you feel personally called out. It's because the cost of not upgrading, whereas the upgrade is too painful to go from Spring Boot 2 to 3 or Java 8 to whatever. The cost of not upgrading compounds faster than just doing the thing, ripping off the Band-Aid, upgrading as soon as possible, as long as it's stable. That's me saying that, not him. I don't know how they feel about stable versus not. But if there are libraries out there that are all compatible Spring Boot 4 and working properly there, and you're on Spring Boot 2, and you can't use them or you can't use any of the new features that they have, that costs you in the long run. And it costs you more than just sucking it up and upgrading now. Speaking of which, when Netflix upgraded from JDK 8 to JDK 17, they got 20% less CPU on garbage collection just from G1 improvements across those releases. And G1, by the way, is short for garbage first. It's been the default garbage collector on the JVM since Java 9. Then JDK 21 brought generational ZGC, which you guessed it, stands for Z garbage collector. Great name. I don't know why they didn't just call it Zero garbage collector, but it's literally Z garbage collector. But the idea behind it is that you basically have zero stop the world pauses because it does most of the work concurrently while your app is running. And the generational part, it was new to JDK 21. And what it means is that ZGC now separates the young objects from the old objects. Most young objects die young, so you collect all of the young objects very frequently, and the old objects pretty rarely, which is really good. Big efficiency increase for services with the long-lived caches and lookup tables, which Netflix has a lot of. So what did Netflix do? They made ZGC standard, the standard garbage collector for all of their services. Not just the high RPS services, but all of them. Because Netflix has super aggressive IPC timeouts. Every request during that pause would fail, retry, create more load. Services under GC pauses would just cascade into the rest of the cluster, and with ZGC, pause times dropped to 0. And now virtual threads. If you watched my last video on this, you know that Netflix had a false start with virtual threads. They rolled them out and everything started deadlocking because of the thread pinning issues. Synchronized blocks were pinning virtual threads to platform threads. And they ended up with deadlocks where every platform thread was held by a virtual thread, waiting for a lock held by another virtual thread that could never run. But JDK 25 fixes that, so Netflix is giving it another shot. They're rolling out virtual threads again. We'll see how it goes. Now, to actually use virtual threads on your application code, not just let frameworks use them, you basically need structured concurrency. And this is where it gets interesting because Paul shows a code example that looks perfectly fine, but it's broken. Look, you do structured task scope.open, then scope.fork. The moment you fork, a new virtual thread is created, which is the point, right? But it's a new thread. And here's the thing that breaks everything. Most Java frameworks store context on thread local. Spring Security stores the current user there. Micrometer stores the current tracing context there. Database connection pools store the current transaction there. Basically, any implicit context in a Java server app lives in thread local, and thread local values do not automatically copy to new threads. So what happens? Your forked tasks run with empty thread locals. Your REST client calls fail because there's no security context, and you can't even debug it because you have no traces. The code looks correct, it compiles fine, it passes the basic tests, but it silently breaks once it gets into production.
These thread locals don't automatically get copied to a new thread. Now, this is not a new problem with virtual threads. This has always been a problem, and that is where the whole topic of context propagation comes in. But it's almost invisible in this case.
And the thing is, scoped values were supposed to fix this, which are a new Java feature finalized in JDK 25. They're like thread local, but just able to work properly with virtual threads and structured concurrency. But Paul admits there's no practical migration path from thread local to scoped values. I mean, every framework in the Java ecosystem uses thread local. So rewriting all of them to use scoped values, well, Paul said he doesn't really see a good path forward without diving into the framework deep in the stack and just doing it. There is a workaround though that he shared. When you call structured task scope.open, you can pass it a custom thread factory. And in that factory, you use a library called micrometer context propagation to manually copy the thread locals into the new virtual thread. It's not as efficient as scoped values, but it works. So you can use structured concurrency today without throwing away all of your existing frameworks. So if you're a Java dev looking at virtual threads and structured concurrency, this is something that you definitely need to take note of and figure out if that's the route you want to take. All right, it's time to get back into some more AI stuff. I gave you a little break. I didn't just talk about a bunch of AI stuff in this video. But honestly, this one may be even more interesting than the Claude Code migration stuff. And that is Netflix is building agentic workflows directly inside their Java microservices using Spring AI, and yes, in production. And one thing I really like is how Paul laid out this taxonomy, if you will. Because having AI in your app means a lot of different things to a lot of different people. So we gotta clarify some terms here. And all of these are different architecturally. So you have the simple LLM call. You add it to your existing Spring Boot app and it calls for something. Summarize this. Classify that. This seems like where most companies for some reason are trying to use AI and integrate it into their app. Just some simple little thing like this. Really just to say, hey, look, we have AI in our app. But the next level is agentic workflow. Multiple LLM calls stitched together in a more complex flow. Maybe an LLM routes a request first. Is this a question type A or type B? And based on the answer to that, it sends it to different handlers. Maybe you chain LLMs, maybe you run them in parallel. But the important part, and Paul hits on this quite a bit, is that you still control the workflow. You define the steps, the LLMs are just tools within those steps. And then he says level 3 is the autonomous agent. This is like Claude Code and Codex. So yes, you're still in control, but how he says is like you give it a prompt and then Claude Code goes off and figures out all the steps and implements all the steps. Obviously not all of us use it that way, but that's generally the idea. And Netflix uses level 3 for the migrations. That's the Claude Code Spring Boot 4 migration story from earlier. However, when it comes to this for features inside their Java services, it's more like the level 2, the agentic workflows, the chain together LLM calls. And they do this because they want the predictability of knowing what steps happen in what order, with LLMs filling in the smart pieces in between. And here's an example that Paul walks through. I think it perfectly shows why agentic workflows are actually useful. And if you're a Spring Boot dev, you've probably seen this problem. And that is you start your app for a test or local dev, and it takes like 30 seconds to boot because there's some Spring Bean somewhere doing something slow during initialization. And then multiply that by a few thousand services and there's Netflix. So Netflix had this problem at scale. So a few years ago, they built a profiler for it. So when you run your Spring app, you get a breakdown of which beans are slow during startup, which is pretty useful, or so you think at surface level. It's not. Well, kind of. The thing is, the problem wasn't actionable because the slow bean might be inside a library you don't own. So now as a developer, you have to go find that library source code on GitHub, read through it, figure out what's actually slow, and decide if you can do anything about it, which is a whole lot of work just to get to the start of the work. So this year, what they did was they added an agentic workflow on top of the profiler.
So you get a summary that says, oh, there's some serious issues in certain Spring Beans going on. It takes a lot of time to initialize. It might be loading data. And we can actually click through and it says exactly, okay, this particular class in this particular library is causing this problem. Maybe you should think about doing something more async. And now as a developer, I actually have something actionable and I can go and fix this code.
And this is a perfect implementation of that agentic workflow level 2 that he was talking about. The profiling data is already sitting in the database. So they have step 1 in this workflow where it's feed into the LLM and have it tell you what's worse. And then for step 2, for each of these really bad ones, go fetch the source code for that library. Step 3, feed the source code into another LLM and ask it to diagnose the actual problem. In step 4, it ties it all together into a recommendation for you, which again, you're not just asking it to, hey, figure out how to speed this thing up. No, you have 4 actionable steps, predictable steps. And Paul said that it wasn't very hard to build this on top of Spring Boot and Spring AI, which is nice. And here's why I was very excited about making this video, because I feel like a lot of the Java devs, at least some that I've talked to, are not necessarily at the forefront of using AI to help them code. Not to vibe code for them, anything like that. But a lot of them are kind of stuck in their ways. And if I'm not talking about you, then I'm not talking about you. But here, you see how Netflix utilizes AI. I think they can use it in many different ways and many more ways that could greatly benefit them. And maybe they do. Maybe their software engineers do on a regular basis help it complete their tasks, but that's not what was talked about here, so I won't even go into that. But you can utilize any of what Netflix is doing for Netflix in whatever you're building. And maybe you tried AI 2 years ago or even a year ago, but it is a lot better today in general, but especially for Java. And if you don't want it to cost you an arm and a leg by using Opus 4.7, GPT 5.4 is really good. And as you can see, Spring has Spring AI. They have it built in, easy for you to use. There's a LangChain 4J, which is the Java port of LangChain from Python. And it's not just a one-off thing. It's pretty mature at this point, widely used. And what's funny is Paul specified the LangChain port from Python to Java because he was going into this whole thing about how AI was always good with Python, and people thought that they would have to switch over to Python if they wanted to use AI instead of using Java, which I never had that impression when it came to AI. But I don't know if your impression was, hey, AI is only for Python like Paul's was a couple years ago. It's not. It's really good at a lot of other programming languages and tools and frameworks and libraries as well. And all of these, I don't want to say all, but a lot of these are building specifically for AI to be able to utilize their tool, their library framework, whatever, even better. Or don't use AI. I don't care what you do, frankly. So that's the 2026 edition of Netflix's Built on Java, which has a lot more AI stuff in it than maybe you expected, because I don't think there was much talk of it at all last year. But now Netflix is using Claude Code as a headless migration engine for their entire Java platform. They're building agentic workflows with Spring AI inside production microservices, and the Java platform team in Netflix said that using AI for migration cost less and was easier for them than using a deterministic migration tool like OpenRewrite. Crazy things are happening, and this isn't just in TypeScript or whatever else. This is happening in Java, in Spring Boot. You know, the language that is supposedly dead that nobody cares about or uses anymore and crap like that. Running on a JVM that just keeps getting faster and faster every release. So, I mean, if Java's dead, Netflix didn't get the memo, and somehow they're doing really, really well with it. And that's about it. Again, listen to Paul's talk. He talks a lot more about all of this. It'll be linked below, and please upgrade from Java 8. I'll see you on the next one.